This is a walkthrough of Problem 2 on Practice Exam 2 of Module 3 in the book Problem Solving Guide for Mechanics and Thermodynamics. Problem 2. A chandelier in a first-class car leans back 10 degrees from the vertical when the train starts from rest and accelerates. If the acceleration is constant, how much time will it take the train to get up to the cruising speed of 40 meters per second? Let's start with a good diagram. There's a chandelier leaning backwards at 10 degrees because the train is accelerating. What are the forces on the chandelier? We have gravity downward, and we have the tension, like that. The chandelier is accelerating the same direction the train is accelerating, to the right in the diagram. Let's put the x-axis horizontal along the direction of the acceleration. When we do that, then we have the sum of the forces in the y direction is 0. The y coordinate of the chandelier is always 0. The chandelier never moves up or down. Nothing's really happening in the y direction. It's all in the horizontal direction. So the acceleration in the x direction is the acceleration of the chandelier because the chandelier is accelerating in the x direction because we put the x-axis in the direction of the acceleration. It's given that the chandelier is 10 degrees from the vertical. We can put that in, 10 degrees. Now we can write the sum of the forces in the x direction is ma sub x, and that's t sine 10 degrees. The sum of the forces in the y direction is t cosine 10 degrees minus mg, and that's ma in the y direction, which is 0. However, this might not be obvious to those who have done thousands of force problems and are not Jedi masters in trigonometry and physics yet. So first, because we want to understand and we want to see the physics, we want to see what's going on, let's break up the tension into horizontal and vertical components on the force diagram. So instead of tension off at some angle of 10 degrees, we're going to put the x and y components on the force diagram, like this. See that? We just changed that tension at 10 degrees to t cosine 10 degrees in the y direction and t sine 10 degrees in the x direction. Those are identical. There's the t. The cosine of 10 degrees is the adjacent side, which is the y component, and the sine of 10 degrees is the opposite side, which is the x component. There it is. Now, we can see that t sine 10 degrees is the force that's pulling the chandelier in the x direction. That's the force that's accelerating the chandelier. T cosine 10 degrees is just holding up the chandelier. T cosine 10 degrees balances the gravitational force. Now, with a complete understanding of what's going on, by looking at the figure, we can do the math. And now, instead of writing the sum of the forces in the x direction, in the y direction is ma sub y, and that's 0, we're just going to balance those two forces. We're just going to write t cosine 10 degrees equals mg. The result is the same. We can write t cosine 10 degrees minus f gravity equals ma sub y, set a sub y to 0, and then algebraically put mg on the other side. But if we look at it, we know t cosine 10 degrees balances f gravity because nothing is happening in the y direction. And we don't have the mass of the chandelier, but we can solve for t by dividing both sides by cosine 10 degrees. In the horizontal direction, we have one force. It's t sine 10 degrees, and we set that equal to ma sub x. Now we have an unknown. We have t and a sub x in there, but we can get t from the y direction. T is mg over cosine 10 degrees. So I'm going to take the expression we have from the y and put it into the x, like that. T is mg cosine 10 degrees. I'm going to stick it in there into the x equation. So we have mg over cosine 10 degrees, which is the t, times sine 10 degrees is ma sub x. Now the masses cancel, which means it doesn't matter what the mass of the chandelier is. It's going to be 10 degrees if the train is accelerating the same way. Sine over cosine is tangent, so we can write a sub x is g tangent of 10 degrees, and that's 1.76 meters per second every second. How long would it take to get to a speed of 40 if it's accelerating at 1.75 meters per second every second? Well, if it was 2 meters per second every second, it would take 20 seconds. If it was 1 meter per second every second, it would take 40 seconds. If it was 10 meters per second every second, it would take only 4 seconds. So it's going to be something between 20 and 25, I'm guessing. We can use the equation, and we get 22.7 seconds, and I'm happy with that. That's problem 2. Good job.